Okay, so good morning. Great to be here. I spoke at Øredev many years ago, and it's great to go and see how it's grown. This is a really, really huge audience, and it's cool because I have some interesting things I want to go and talk to you all about. Hopefully you'll find them interesting. Some of you, if you looked ahead of time and you said, okay, well, I wonder what's happening at the conference, and you look at the different things, maybe you saw the title of this keynote, and you're kind of like, what is that? Socio-technical modeling as a practice. It has a bunch of words, and you can kind of like put them together in your mind in different ways and try to figure out what this is about. It is a relatively new topic, and it really has to go and do with things I'm kind of noticing in the industry as people make decisions in organizations. And I think, this isn't really the best title for what we're going to talk about today. In fact, I'd say, as a practice, maybe I'll kind of drop that. The whole notion of modeling, we're going to talk about modeling a little bit, but the main thing I'm going to talk about today is really socio-technical forces, okay? The things that we can see in the context of, say, architecture, process, and organization design that can help us make better decisions as we're moving forward with things. And it is kind of odd with this because, nobody's asking me to go and do this sort of thing. It's kind of like this weird thing of just as you work with people, you start to see different patterns and see how they kind of play out, and then you start to say, well, gee, here's something that we can be aware of, and if we're aware of this, we can make some better decisions on various different things. So I want to kind of start out in a rather abstract way. Has anybody ever seen the word isomorphism before? Know what that is at all? And it kind of depends. If you're basically working in like something which is kind of like mathematically related, you may come across this word. It basically means when two things have roughly the same shape, or almost exactly the same shape. So you'll see this sort of thing in graph theory all the time, right? You ever see graphs, right? You have basically like the dots and you have the lines connecting them. And we can use graphs to represent many, many different things. But it's often the case that you can find two things that look like they have the same or a different shape, but actually when you look at the way that things are connected, it turns out the connection is exactly the same. And that's kind of surprising for us sometimes. When we see this sort of thing, and recognize that we have fundamentally the same structure in a couple of different places, often it tells us something deep about the way that thing is oriented and the things that you can do with it. So, got a very interesting question for you here. This diagram right here, this connection diagram of a bunch of things. These things here, do you think they're teams or do you think they're microservices? Both, right? Now it's kind of funny. I'm not going to tell you which one it is, right? But the fact of the matter is they're going to look the same roughly, okay? There are certain dynamics to networks that basically lead to certain structures kind of emerging over time. And quite often it doesn't really, I won't say quite often, always, it doesn't seem to matter what the substrate is. It doesn't matter whether we're talking about services, for instance, in the world, or we're talking about teams, or we happen to be talking about companies in a city and stuff like that. The same kind of network dynamics tend to kind of like happen. And the reason why they tend to happen is because there are common forces regardless of what the material is, what the things are that happen to be interacting with each other. And this really kind of points to a rather deep level of understanding systems. And one of the things that I think makes software development so fascinating is that we deal with all kinds of systems. It's not just, the code that we write. We deal with things in a socio-technical system where we have to deal with the forces at play within the organizations we're working in, also all the market forces that are involved, and then the forces in broader society. And having a mental toolkit for going and dealing with these things is often the best thing that we can go and do going forward. So to kind of like sort of seed the discussion here and talk a little bit more about this, I'm going to go and talk about something I saw a while back at a company. They essentially had this thing where they had several teams that were basically given the mandate to go and do some testing. Okay, do some acceptance testing for their individual pieces. And they'd been doing manual testing, but of course they have to go and make that first leap into going and doing some automated testing. And everybody's kind of been there at some point, right? You have to do automated testing and you have to do various different things. They were working in a very particular domain and they had several different products. And they did some looking to go and kind of like find if there was a good off-the-shelf framework that they could use. But because of the peculiarities of their domain, they couldn't really find anything. So what they started to do, each team was basically develop their own acceptance testing framework. And it just seemed like the best thing they could do going forward. Now, of course, that works for a while, and then people start talking to each other over lunch and discovering that, hey, we're duplicating effort here. What should we do? And they decided to go and actually take some of the code that they had for testing, kind of move it into a repo that was available to all the teams, so that they can actually go ahead and start, just using it and have a common framework to use across all these teams. Now, the thing about it is that, there wasn't like a dedicated team to that framework. Just, you see this little timeline here. Essentially, just some people would go and work on it for a little while, and then they'd kind of roll off and do something else. Other people would work on it for a little while, then they'd roll off and do something else. And, it's kind of funny because you could actually see that in the code. What I saw was like a base class at the center of this framework, and essentially just had lots and lots of different areas of functionality. And these were all pieces of functionality put by individual teams to go and solve their particular problem. And if you can think about things in terms of, like, say, object orientation, we kind of notice that this is a thing that happens over and over again, where it's like there's this thing, you have one class, and it ends up going and getting all the work in it. It ends up being like a God class, for instance. Now, the thing is, I didn't have this backstory about the teams. I just remember looking at the code and looking at this and saying, wow, this is kind of interesting. I wonder what happened here. And I wondered a little bit, but the fact of the matter was I kind of knew in a way. Because the thing that's interesting is that the things that we basically do in organizations end up mirroring themselves in code. Have you ever heard about this at all? Yeah, so this is like Conway's law. We'll talk about that in a few minutes. But it's really kind of fascinating when you notice this, because then you just basically see how intermingled we are, okay, with the organizations we're in and the process that we use and all these different things. I don't know if anybody's ever heard of Gerald Weinberg. He was an early consultant in the industry. And one of the things that he used to do as a practice is basically tell teams he was going to visit to send some copies of their code over to him first, before he visited the organization. And people would say, why? And he said, well, I want to understand how your organization works. And he was able to tell this by looking at the code. Kind of fascinating, right? Now, if we look at this, we can say this situation might be not the best situation. It certainly isn't the best situation for the code, right? We end up with this kind of craziness going on here. How do we solve this problem? I just outlined for you, a dynamic. We have a bunch of teams. They basically have a common problem. They put code in a common place. And then they have this dysfunction where the code kind of falls apart in a way. Well, this is where we've been for quite a while, that we basically find problems in the industry, and then we talk about how to fix these particular problems. But I want to go and stop for a second and say, hey, instead of going and trying to solve the problem immediately, what do we do to go and try to understand the dynamics behind these things? Because once you understand the dynamics, then you can basically consider a wide variety of different things that you might do to go and solve the problem. It is like a side effect of our engineering focus that we quite often say, it's like, oh, I've got a problem, let me get a solution. But doing the analysis to go and understand what's at play can quite often give us a wider envelope of possibilities to go and solve problems. So this is my obligatory Conway's law slide. Anybody ever see this at all? Okay, it's kind of like this jokey take on what it looks like inside of various different organizations, how they must be oriented based upon their culture and what we see from the outside. Notion here is that Amazon basically has a hierarchical structure where you've got Bezos at the top and breaks down into all these services and stuff like this, but things still kind of flow from the top down. And if you look at Google, it looks like, when you look at decisions that come out of that organization, they are incredibly networked at the lower levels. It causes a lot of interesting things. I think my favorite one with this is Apple, right? Like Steve Jobs is gone now, but it seemed like he was central to the entire organization in the beginning. So it's kind of like everybody would be tied into him. Not exactly a micromanager, but many, many things flowed from him within the context of his work. But this is, essentially Conway's law that I mentioned a bit earlier. And I'm going to kind of assume that most people here kind of have run into this concept before. First written up by Mel Conway in 1968, believe it or not. He made the observation that when you design something as an organization, the structure of your teams ends up mirroring itself within the structure of the thing that you produce. And it took him a while to go and actually get this published because he didn't have any data about it, but everybody kind of knew it was true. And since then, there's been a lot of research to go and show that this dynamic really happens. So I'm not going to belabor this a bit because I think if you haven't encountered this, you really need to go and dig into it a bit. Does anybody know why it would be the case that the structure of the things that we build mirrors the structure of the teams that produces that? Well, it's actually rather obvious once it's kind of pointed out to you. When you have separate teams, communication is easier inside the team than it is across teams. So it's easier for me to go and collaborate with the people close to me and say, hey, I'm going to work on this and we're working on this together, but we don't really know what's going on over there because we only meet with them once a day or once a month or once a week. So let's put an interface between our stuff and their stuff. And so this just tends to be a natural way that systems grow when you have distance between groups of people working. And the distance doesn't have to be physical distance. It can be distance in terms of like what roles you play. It can be distance in terms of how often you talk, like it's a temporal distance. Anything that kind of impedes communication can go and cause these kind of effects when you're developing software. So the thing about this, though, is it does lead to this idea that code and team structure are somewhat isomorphic. And I'd just like to go and sort of like say, look, you know, here's the thing. This is one force, excuse me, one force that is present in software development. What other forces are there? What other things do we kind of encounter? Well, here's another one. Does anybody know what this is a picture of at all? It's kind of like a power law distribution, kind of like a Pareto distribution. And, sorry? What kind of? Yeah, which files change the most? Yeah, that as well, right? This is basically a picture of like a power law distribution. Sometimes they're called Pareto distributions. If you've ever heard of the 80-20 rule, this kind of like applies in this case here. Generally speaking, in many dynamic systems, and say most dynamic systems, when people are able to make a choice between one thing and another, you end up with a lot of people choosing one particular thing, and that's like high frequency on the left-hand side here, and then a long tail of people making other choices. So this happens in like, say, airport hubs, right? You have some airports that basically have lots and lots of connections, like Heathrow is like one of those. Atlanta within the US is like another airport where you have many, many connections. And then you have the smaller airports that don't have quite as many connections. And the reason why the ones that are smaller don't have too many connections is because if they have at least one connection to the bigger airports, people can get to where they need to go, right? This kind of thing of going and having preferential attachment goes and leads to this interesting dynamic. But it's not just airport networks. It's also income distribution. Amazingly, it's also things like the size of things inside of your code, right? If you graph out in your code the size of methods for your code base, what you'll find is that you have thousands and thousands of small methods, 1 or 2 lines, and then only a couple of methods that are like, you know, about 100 lines or 200 lines or 1,000 lines, right? These dynamics play themselves out in many, many, many different systems. And it's kind of fascinating because if we're aware of this dynamic, then we can start to go and think about what it means for quality, what it means for various different aspects of the work that we're doing within organizations. It's funny because I think sometimes just the lack of understanding something like this can really kind of get in the way of various different things. A story I tell periodically is that I remember visiting an organization where they basically had code that was kind of, it seemed kind of nice, except it seemed like the names of the methods weren't matching the bodies of the methods all that much. The code, what the code was doing wasn't matching the names. Methods were all relatively short, so it seemed kind of decent, but it was just kind of odd that way. And I was walking around the organization and I basically discovered a sign where they were talking about what their team rules were. And one of the team rules was that methods should never be longer than 15 lines, right? Do you kind of see what happened with that? What happens with that is if you essentially put a hard boundary on something which is really more of a natural curve like this, then you end up going and distorting things. You have something which kind of wants to grow to be a bigger method, but if you chop it because you just feel that you should chop it, you end up distorting the code base a bit. It's nice to take a big method and break it down into smaller pieces, but you can't always do it without, you know, gumming up the works a little bit. So the best we can hope for is to have fewer large methods, but they are going to happen. This is very much like in signal processing. If anybody's ever seen sine waves, like a nice curve, Does anybody know what distortion looks like? Distortion looks like this. When you hear a distorted guitar or something like that, it's basically the top and the bottom of that pure, beautiful sine wave is chopped off, and it hurts your ears. Okay? So we can distort code bases by going and chopping things artificially. That's just a thing that we can do, right? So yeah, this is a place where understanding of system dynamics can help you, make some better decisions as you're moving forward with things. That's code. Somebody shouted out a little bit earlier about when I had the picture of the distribution, the Pareto distribution. They said this is also commit frequency in code bases. Guess what? It is. Most of the files in all of your code bases are only committed to once or twice or 3, 4 times, right? There are a couple of files that are committed to hundreds of times. And that's that same kind of power law distribution. Sometimes it's called the 80-20 rule. Like 80% of the effort is applied to 20% of this particular thing. You ever hear of that 80-20 rule? Right. Very important dynamic for us to understand in software development. So I've been talking about code, right? I've been talking about the size of methods and things like this. But what about heroes? Anybody have any hero programmers on their teams? Do you enjoy them? Wow, where are the hands? All the hands disappeared, right? Yeah, we've had this long-standing ethic within software development that we want to go and basically not have people go and sort of like do way too much work and sort of like hog particular areas of the system and do various different things. And we also recognize that this thing of like if somebody sees themselves as a hero, it's a toxic thing in a team, and I totally believe that. That's why I was kind of shocked to go and see this paper come out in April of this year. And it looked like it was being deliberately provocative. How to prevent, well, actually not this one, how to prevent coding heroes from destroying teams. This is actually the paper I was talking about. Sorry about that, more slides. Why software projects need heroes. Lessons learned from over 1,000 projects. Now that's provocative, isn't it? The idea that we need heroes. Yeah, I can see people already, they're grumbling like, rah, 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 right? There was discussion of this on an online forum, and I just couldn't believe how many people were just like really upset because they thought this is like sending the wrong signal in the industry. But it turns out that the writers of this paper had a very specific idea of what they meant by a hero. And what they were talking about was essentially this thing that when they were doing repository analysis of open source projects, they found that in over 90% of 1,000 projects, most of the commits were made by 20% of the developers on the project. And not just the commits, also the contribution in terms of the online conversation and stuff like this, right? And that's kind of stunning. And of course then the conversation becomes, well, surely that's true of open source projects, but it's not true of proprietary projects. And if you talk to people that do repository analysis inside of organizations, they'll point out that the same thing happens also, right? You just basically have some people doing a lot more heavy involvement in the code than other people do. Now, I come from the agile software development, portion of the industry, and the immediate thing is to go and think this is dysfunctional, it needs to be fixed. But then there's other things that are involved with it too. Turns out one of the other results in the paper is that the contributions made by this 20% actually were of higher quality, fewer bugs, than the contributions made by the other people on the team. So what does this mean for us? It's kind of funny, isn't it? Well, I think it's really a dynamic that we should kind of understand. And I also think that it's important for us to go and kind of separate out the things that we might think is cultural from the things which are kind of like opportunities for us as well. We know what toxicity is in organizations, where you get this thing where it's kind of like some people are hogging work and they basically think they're better than somebody else and stuff like that. But on the other hand, there is this dynamic where it seems like if you spend a lot of time working in a particular area of the code, then chances are you're probably going to be the best person to go back and do those things because you're so deeply immersed. You have a deeper mental model of the code than other people might. So you end up in this place where you're doing more of those contributions. And it just ends up being a dynamic that kind of feeds itself. So I'm not really sure whether we have to go and fix this or not, but it's a dynamic that's, something that's really kind of worth thinking about. What I think this is kind of powerful to think about is in conjunction with things like team size, for instance. Because one of the things that they pointed out in the paper as well is that this Pareto distribution of quality tends to basically disappear as the team gets smaller and smaller. If you have a very small, well-focused team, then a lot of the contribution among the team members ends up being a lot more equal, and then you end up having better effects. But in a way, we kind of know some of this already, right? Is it better to have a big team or a small team? Have you heard about 2 pizza teams, like from Amazon? There's so much research around this that you really want to go and have a small team of like maybe 5 people, so 5, 6 people on a team working together. Because as you grow, then you have more and more intercommunication paths, and it becomes harder to go and have consensus about various different things. So yeah, there's this dynamic that we just should be aware of when we're basically organizing ourselves. So I guess the thing to point out is that cognitive limits constrain structure. And this is true with the Conway's law thing. It's also true with this Pareto dynamic with team size. There are other things as well. Dunbar's number, you ever heard about this at all? Okay, Robin Dunbar, who was a sociologist, anthropologist, hypothesized, and it's been actually like experimentally verified quite a few times, that there's a limit to how many people we can relate to. Once you get past about 100 or so, it's like you can't recognize people by sight and name quite as much in a particular context. And as that happens, then it becomes kind of important to go and have, you know, your structure kind of break down into substructures a bit more. And you'll see this over and over again, that as startups grow past the 100 mark, they invariably need to go and structurally transform into a more federated structure in order to go and actually start to go and achieve the effects that they want to go and achieve. So again, that's another dynamic that gets into the work that we do. And scaling, you know, that thing when basically we are growing from one level to another and structure having to change. There's a lot around that sort of thing too. That's something things we should be aware of. Have you ever heard about this at all? Galileo scaling law. Okay? This is an interesting dynamic of physical systems, but I think it applies to social systems as well, social and software systems. Poor old Galileo, after he offended the church and thrown in prison for years. You know, you're sitting in prison, what are you going to do except think and discover amazing things? What he discovered was that there's a limit to any structure that we have in nature, and even the things that we build as people, right? Like buildings and stuff like that. As physical things grow, the volume increases faster than the surface area. And we can see that as, you know, volume increases as the cube of n, but surface area increases as the square of n, okay? So this kind of ratio gets us into this place where basically, you know, you can't build the same kind of building at this scale as like at another scale. The membrane, like the surface, has to be more reinforced. You need more surface area going forward as your volume grows. And it's the reason why, you know, essentially we can't have a mouse the size of an elephant. That structure doesn't work at that scale. And this is very much true for software as well. There's certain things that work at particular scales, and other scales they don't quite. And we just talked about organizations as well. Organizational structure has to change as you get past the 100 mark because of the dynamics of the underlying system. So yeah, that's a thing, and I think you can also look at this in terms of what happens to us socially. Have you ever seen cliques in teams? Team gets to be a certain size, but then suddenly you have 4 or 5 people that all hang around with each other and they have coffee every day. And then maybe they start making some decisions together or talking about things that other people aren't part of. And then there's like some tension in the team because of this. Have you ever seen this kind of thing happen at all? It happens. And you can basically be very diligent about keeping conversations in the broader group, you know, but this happens in all social systems. You know, essentially it's like happens in soccer teams, like football teams as well, right? I think that some of this is really just a scaling effect. As the number of people grows, then basically it's like the number of possible connections grows. N people leads to n squared connections. And there's a lot of tension involved in keeping that all together. So your tendency is to go and break off into smaller groups where you can have a smaller conversation. And that's just what tends to happen. So scale has some inherent limits. And we can try to scale things and force it. But, you know, there's a reason why we just kind of like tend to work better in smaller groups. The big challenge for us is to go and actually develop software in ways that we can have smaller groups work on it, and then find ways to make those smaller groups coordinate with each other well. Now, this same tension, it's kind of interesting. As things grow, they start to break apart into smaller pieces internally. We can see the same thing inside of software too, can't we? If you have a class in an object-oriented system, right? How many responsibilities should a class have? Right? The idea is that we have the idea of the single responsibility principle. Classes should have a single focused responsibility. How can you have a single focused responsibility if you have 50 or 100 methods? Invariably, if you have like a large number of methods, what goes on is that there is internal differentiation. You start to notice that some things are related to other things more than they're related to other things. And that's just a natural tendency of all systems. As things grow, internal differentiation tends to occur in any dynamic system. And you can see this in biology as well. Essentially, as things grow, they start to differentiate internally. Cell mitosis, for instance, or meiosis, breaking apart into separate cells, same kind of pattern that occurs. And so one thing I've been kind of like doing off to the side is kind of like accumulating, examples of this particular thing, because when you see that dynamic in many different places, there's things to learn about it. And so it's a fun thing to go and deal with. Single responsibility falls apart as we scale. We tend to break apart into smaller responsibilities. So yeah, there's interesting things about all this. The way that we modularize systems, the way that we modularize teams, and interesting tensions that can come from this. Anybody ever use feature teams at all at work? Okay. Yeah, it's kind of interesting. Feature teams are a really kind of powerful way of going and orienting our work, having our work stretch, or having our team's focus stretch across many different areas of the system. It's funny about this, though, because the thing that had happened early on when feature teams were first put out into the industry was that they were offered as an alternative to component teams, where you have people that kind of understand a component so well that they've developed all this deep knowledge that they can just concentrate on it. And the idea behind feature teams was to go and say, look, let's get some cross work happening across different areas of the code base. Is there anything that can go wrong when you do that, though? Well, it's kind of interesting. One of the things I've seen in my experience with feature teams is that it's not a pure good in a way. Component teams allow you to go and have deep focused work, but then people can become siloed in that particular thing. The problem with feature teams is you can very easily get into a situation where you're making changes to things that you don't really understand well enough, because it's kind of hard to find a person who can tell you. And then you start getting this deterioration of things because you're not as well informed as you would be if you basically had deep knowledge of that particular area. So there's a tension between these two things, and it really goes and pays for us to go and see that kind of tension. To see that essentially, as we've fractured our work in different ways, and fractured the way that we do our teams, that we have a trade-off to make. The trade-off is between cross-training across many different things versus possibly getting suboptimal change because we don't have enough deep context. The trade-off for component teams is, yes, we get deep context, but then we get people who get our attention focused too inward and don't really see what the context happens to be. So which is better, component teams or feature teams? It's a trade-off, and you can basically go and decide in your organization which particular things need what based upon risk profiles and various other different things. Another thing to think about, though, too, is if we take that stuff to heart that I mentioned earlier about smaller teams being better, can we become way more productive by going and scaling things down a bit? Here's the thing to think about as well. Team, tools, and code. Okay, these are like three components to some of the stuff that we do, right? For each one of these things, it's kind of like we have a certain amount of code, we have a certain number of tools that we use day to day, and we have a certain number of people that we have on the team. Is it good if the numbers are high, or is it better to keep the numbers low? I mean, all things being equal, it'd be great to work on less code, right? You can concentrate on it a bit more. Maybe fewer tools might be better because then there's less thing of trying to go and understand in depth how to use various different tools. And I think anybody would argue that a team of 5 is way better than a team of 1,000, for instance, right? There's a certain amount of cognitive load that comes from going and dividing our effort across a large code base, many tools, and communication with many peers. So I wish that we could kind of quantify this. In my mind, it looks kind of like this, that it's almost like there's a scaling factor for the numbers of all these different things. And we should just keep this entire thing below a certain threshold. It's ideal for us to go and actually have smaller teams, fewer tools, and less code to work on. But of course, business being what it is, we're necessitated to go and actually do bigger and bigger things. We have to kind of figure out how to structure that. You know, what's the singularity for this? Is one person working on a small amount of code with only one tool, right? Is that a good situation? Depends on what you're doing. And some things can work out pretty well that way. I mean, you become the human cyborg, right? Okay. One of the things that was really eye-opening to me was to see a couple of years ago this blog by Ben Rady called Powers of Two. I don't have the URL up here, but it's easy enough to Google. What he was talking about was this experience that he had at his company working on a two-person team. So it was him and one other developer. They'd come in every morning, they would pair on things, everything they were pairing. They would test everything. They had their customers in the room, they could just go and call over and say, hey, what about this? And they didn't have a backlog at all because the work that they were going to be doing was determined every day by being reactive to the people they were developing the software for. So no backlog, a lot of pairing, a lot of testing. And the thing that he writes in this is it was amazing how little process they needed. And it's because they kept their numbers low. And again, you can't do this for every team, for every organization, for every problem. But, you know, it's kind of a thing that's worth looking at. You know, if you can, in certain places, it's a win, isn't it? Have a small number of developers, focus attention on something, and be able to create value. Wonderful stuff. I was talking to somebody at a company I will not name, one of the big companies, over dinner at a conference a couple of months ago. And we started going and talking about this, and the guy I was talking to says, oh yeah, in our company we behave that way. We have two-person teams. I'm like, wow, that's good. So maybe this is more prevalent than I realized. And we started talking a little bit later about the notion of like, well, it's kind of rough with that because, you know, what if one person leaves the company and it's like how much history is lost and stuff like this. And we started talking about architectural decision records where you keep track of all the decisions you make on a team. But it kind of occurred to me that maybe the other thing is that if we get diminishing returns by going and adding developers to a team, maybe it would be better to go and have people that are not doing development join the team and do other things. What if you had a person who basically their entire job was to keep track of all the decisions that are made on the development team, write a concise history of that, and be able to go and sort of index it so it's easy to find out why certain things happened. 2 developers and 1 project archivist. And their job is to look over the shoulder, ask questions, write things up, get their approval, I guess, about, you know, was this really what's going on with us? And maintain that history. So if one person leaves, other people can come back to speed. If both people leave, you can look back and find out what happened on this day 5 years ago. It's possible, right? We could do something like that. We don't really think about these things all that much, though. You ever heard of the book, The Mythical Man Month? Okay, Fred Brooks. One of the things that he talks about there is something that was developed by Harlan Mills. He had this idea he called the Chief Surgeon Programmer Team. And this idea back in the 1960s was, well, maybe we should run teams just like you would a surgical unit, where you have a chief surgeon who kind of calls the shots in the operating theater, assistants, they're basically helping out with various different things. Because his idea was that it's good for software to look like it was generated by one mind, right? And, you know, we see echoes of this now. Mob programming as a way of going and sort of making software look like it was generated by one mind because everybody's working on it all in tandem. It seemed like that idea kind of fell apart for various reasons. IBM tried it for quite a while. But this notion of having one person that's kind of like the programmer and then other people support them is a thing that, you know, it's a possibility. Maybe we should say 2 programmers now. But I think, yeah, getting people to go and help in auxiliary roles so that we have fewer people and more coherence in a system might be a powerful thing to think about. But, you know, we scale. So we have things like the Spotify model, for instance, right? We have different ways of going and organizing ourselves, matrixing across things. But these are all things which go and deal with these dynamics in particular ways to try to solve things. Have you ever heard of this guy at all, Bruno Latour? Okay, so French sociologist. One of the things that he came up with was something he called actor network theory, which was kind of radical. And I remember hearing about this from Brian Merrick in the industry close to 20 years ago. And I remember doing some reading into it. The fundamental thing, without going in and getting too deeply within it, was to go and basically sort of essentially draw the graph of the system. And when you draw the graph of the system, then you're able to understand the dynamics a bit better. But his revolutionary insight, in a way, was that the graph doesn't contain just the people, as most sociologists might go and think. It also contains the physical objects within the space. And that essentially you can see the dynamic between all the different things that you're going and working in. And a lot of what I'm talking about here is like, what are the dynamics between the code, the tools, the people, stuff like this. We have this opportunity to be able to go and sort of like look at them without privileging the people over the code or the code over the people and stuff like that, and say that if we do this one particular thing over here, it goes and affects things in this particular way. And this is really like a deeper understanding of how systems develop that we can kind of like move towards. Yeah, adding people to a late project makes it later. Maybe adding nodes to a project makes it slower too. The more nodes in your graph, then the more things can be very complicated. So going back to this example that we had earlier, okay, we have our testing application in the very center. We have our crufty code as a result of this. We also have the thing where basically we have people intermittently making changes to this particular piece and then kind of like going away. What can we do with this? Well, I can tell you what happened. Okay, what happened with this was that there were a bunch of different things that were thrown out as things that could be done and discussed. But what happened with this, and I'll go back over what those things are in a minute, what happened was that some of the teams basically discovered it was just too much work to go and coordinate with this main central thing, this testing framework. So they took the code from the central testing framework and pulled it into their own repositories and just incorporated that code and then walked off and had their own version of the framework, which was okay. The other team said, okay, well, we're going to go forward with this framework. So what we're going to do is we're going to go and sort of like dedicate some people to work on it and make like a plug-in architecture so we don't have to go modify that base class over and over and over again, right? So a couple of different things were available to us as things that can be done. You know, one of the things that was floated was to go and let's make a dedicated team for the testing application. But then the question is like, maybe there's not enough work to go and deal with that particular thing. Another thing was like, let's incorporate that code into our projects again. And that's the thing I mentioned, you know, pull it into our own projects, make our own testing framework. And explicit interfaces with a plugin architecture. But there's really like, there's a whole set of things you can basically do to solve these socio-technical problems once you're kind of aware of the forces that are at play within them. I think the central thing about this that I think is fascinating though is that it points to something which I think is the root of a lot of dysfunction in organizations that people don't think about all that much. And that's that code and team are kind of like a unit in a way. And we don't really tend to appreciate this all that much. When you look at that last scenario, I think that the main tension was, here we have some code over here that nobody is tending. And because nobody's working on it actively, then nobody is really there to go and say, well, maybe the best way of making this change is this way. So people just push their changes into it, right? Have you ever seen places where you have like somewhat abandoned code, and then because it's abandoned, it kind of falls apart? Yeah, and so what this means to me is that essentially it's like there's this unit, code and people are like this living thing together. And when you take one away or you remove another in time, then, and when you break that communication thing, then you should expect dysfunction with things. So yeah, this is a thing that can happen, is that essentially these things can become kind of like out of sync. And a lot of this is really something which is almost endemic to software development. When you think about what, say, legacy code is, for instance, I think legacy code, there's many different frames we can apply to it. But legacy code primarily is when the staff turns over faster than the code. If people are coming, going in your organization faster than lines of code are, you know, added or deleted, then you're going to get to the point where basically people don't understand it anymore because they weren't there when it was made, right? So that linkage kind of falls apart. There are many things, many systems that have this quality, where you essentially have two things that work together to go and generate a whole. You can look at like competition in markets, Coke versus Pepsi, right, as a duo, like an intermingling of these two things. But we also have these dichotomies within development as well. Product and development have a tension between them, right? QA and development have a tension between them. And I just mentioned that one with like legacy code, for instance. When you have these things in a system and they basically need to sort of like have communication back and forth to go and feed each other and do well, if you can't basically go and keep that all together, you need some way of going and compensating, right? I'll venture that the automated testing that we do now in the industry is actually a compensation for us not understanding the code well enough because it's grown so big, and also because people come and go on a project and it lives longer than we do. So we generate the automated tests to be able to go and sort of like have the tests become a memory because the people may be coming and going, right? So when this dynamic between the code and the team in time goes and falls apart, we need props, we need compensations to go and keep things kind of going together. The distinction between product and development in an organization, we need the prop of going and having user stories and estimates in order to go and actually sort of tend that communication. There are, believe it or not, some organizations where there is no such thing as a product group or a development group. The developers themselves, the people developing the system, actually make the product decisions as well. Then there's no communication gap. But that's kind of hard to do at scale. So we end up breaking things apart into two separate pieces. Then we need the prop to go and connect these two things together, the compensation. So we have these dynamics. And I think the main thing I'm trying to get across with this as I kind of ramble, it's kind of rambly, isn't it, this talk, is that seeing these forces helps us be able to make better decisions. A story that was related to me recently was utterly fascinating, and it allows us to go and sort of see some of these forces at play. There was a team, okay, that basically was working on the business logic of a system. And they were also working on the user interface for that same system. And we can see that as being these two that rectangle at the bottom that has two sides. Imagine the left-hand side is the business code and the right-hand side is the UI code. But turns out there's actually another team that started going and using the APIs presented by that business logic team. And they were upset because the APIs that they were using were not very formal because the same team was developing the UI as was developing the business logic. So it's kind of like a poor API because they were on both sides of it. You know, it's kind of like there's not kind of like fuzziness because, you know, hey, I can just do this thing here because I just need it over there, and just end up being like a very cluttered API. Ever see anything like this before? Right. So what are the forces at play in this? It's interesting to think about. You know, one thing might be that it's kind of like, you know, one thing that could happen is you could say, okay, let's take these two areas of code and sort of separate them so that they're separate teams, right? So this team can basically be here, and then this other team can basically use that team's product. And that might, using Conway's law, allow us to go and actually form a better API there. And then that better API becomes suitable for other clients. And that would be a way of going and using Conway's law to your favor to go and actually allow you to, you know, solidify an interface because you've got multiple clients against them. You've got to negotiate with those people to do things. That's one possibility. But, you know, the thing about it as well is that this is, another way of looking at this is that this is almost like an encapsulation violation as well. Imagine that this thing is one entity. You have this thing depending upon this thing. You have this thing depending upon not the entire thing, not the code team unit, but depending upon a particular area of the code that isn't really solidified. This is almost analogous to in a system where you have a class and it has private things, and this other class is attempting to go and actually use a private interface inside of that class, use private methods. So the encapsulation stuff that we do in object orientation and in service orientation, it has analogs across an organizational structure as well. And this shouldn't be a surprise. The dynamics that we have in some systems, they're pretty much universal across many systems. And it's just something that we should, you know, kind of like be aware of. You know, there is another solution to this same thing though. You know, you can say, why don't we just go and have people that come from this team come over here and go and offer guidance as they're developing their internal APIs. So I'm going and producing like this cross-cutting team thing where people from here come over here to help out. And this is kind of the foundation of a lot of things that end up being kind of matrixed in organizations. If you look at, say, the Spotify model, for instance, you'll see we have the notion of a guild that goes across tribes and chapters that go across tribes. But here's the thing about this that I think is fascinating, is that when we have our units of people that are working on code, and then we create external, interfaces between them, we start going and working against cognitive load also. We start getting into this place where the team itself might start to feel overloaded because we have people coming from other teams to visit us and we're doing this. How much of my day is about communication with other teams versus going and focusing on the thing I need to go and focus on? So, again, this is kind of like cohesion and coupling, it's encapsulation, and maybe trying to orient ourselves so our work is way more separate than we might expect, and having loose linkages to other teams to go and do various different things. And that might be the way forward with certain things. But again, it's a matter of going and seeing the dynamics. And when you see the dynamics, you can start to go and organize your work and see many more options around the work that you go and do. So, kind of at the end of the talk now, and it's a funny thing with this because I look, what's the imposter syndrome? I don't know. I look back at a talk like this and I say, oh boy, I really rambled here. I basically touched a whole bunch of different things. I wonder how much really came across. A lot of it is very abstract. But, I'm happy that I spoke about this because hopefully some piece of this goes and connects with your work. And if you're interested in this sort of thing, I kind of recommend or hope that you might go and reach out and we get to talk about this a bit more. I think the key thing to kind of reiterate is that we make a lot of decisions in organizations about architecture, about teaming, the organization structure and process. But the intermingling of these three things is very important, and it has lots of run-on effects. And it's easy for us to go and say, well, Spotify did this, let's do that. And if you talk to people at Spotify, they'll tell you, no, you shouldn't do that. They just basically offered up an example of something that was kind of working at one moment in time there. The key thing is not to go and take somebody else's model. It's to be able to develop your own model for what you need to go and do in your organization, based upon the forces that are available to you. This is just like software design, but instead, you're designing communication within an organization and within organizations and process in order to achieve the outcomes that you want to. What's fascinating right now is that many of the people who do things like organizational design and stuff like that, it's a great thing, but I'm not sure that enough of that is really as architecturally as aware as it needs to be. We have like this barrier pretty much within software development organizations that you have people that basically see the teams, they see the products, and then there's the people below that basically see what the architecture is that underlies these things. And that kind of thing where they don't really quite mix together in a way gets in our way. So I hope we're able to go forward and sort of like develop a decent language for going and solving these problems. So I just want to kind of leave it there and just say thank you very much. I hope you enjoy the rest of the conference. It looks like we've got an incredible lineup of fun things for everybody to go and do, and lots of learning. Okay? Thank you very much.